Hi, welcome to our final design project presentation. My name is Khalid.
And my name is Abdurrahman.
My name's John.
My name is Hatem.
And my name is Margot. Our engineering design team was contracted to design components within a small gasoline engine-powered air compressor. We provide specifications for gears, bearings, and the input and output of a rotary shaft, as well as the coupling analysis for the output shaft to the compressor. The gears are from Boston catalog, the bearings are from the SKF catalog. We created our design under the following assumptions that you see on this slide. All systems within the design had to have at least a factor of safety of 2. The input and output shaft needed to be specified for infinite life. And the input shaft has a velocity of 750 RPM, give or take 25%. The client wanted ideally a 2.5 to 1 gear ratio, but was okay with a max of 10 to 1. The teeth on the pinion and gear are full depth, and Weibull parameters were used for speccing the bearings, and the reliability needed to be 95%.
This is a basic construct of what the design will look like. It begins with an input shaft coming from a small gasoline-powered engine. The shaft will be supported by 2 bearings on either side of the interior gear, as shown here, 1 and 2. This gear connected to the input shaft will be the driving pinion gear. Meshing with the pinion gear will be the second gear, which will have a ratio of 2.5 to 1. Supporting that output shaft connected to the second gear will be bearings 3 and 4. Then the output shaft will be connected to the compressor on the other side through a coupling right here. The coupling we selected to connect those 2 shafts will be a Falk T10 steel flex grid coupling. We chose this coupling because it requires minimal maintenance and will support the necessary torque and load values for its use.
First of all, as an initial step, we found the number of teeth of the pinion, so we can choose the gear from the Boston catalog. Then we found the torque using the graph provided in the problem, so we will be able to calculate the contact force and the loading with the shaft. By doing that, we will be able to find the reaction forces for bearing after we have all the forces acting on the shaft. We can find also the diameter of the shaft using Goodman failure criteria as a conservative criteria, and we will be able to find the pitch line velocity and confirm that all shafts has an infinite life. Also, we can confirm that the factor of safety is more than 2, which is the minimum for the system for both shafts. And now, since we have the diameters and we made sure that the safety factor is more than 2, we can choose the bearing from the SKF catalog and check if it's safe or not. Then we will choose the minimum length for the key and for both shafts, the input shaft and the output shaft. And as a final step, we will make sure that the shaft is safe at the stress concentration locations.
Following the methods provided earlier, we did the calculations for the results for the gears, and we found out the number of the pinion teeth is 16. And by the gear ratio, which is 2.5, we got the number of gear teeth, which is 14. And to have the 2.5 ratio, we had to choose 8 as a diameter pitch for both the pinion and the gear to occur the mesh properly. Also, the diameters are 2.25 and 5.25 for the pinion and the gear respectively. And we choose the standard pressure angle, which is 20 degrees. And by using the Boston gears formula, we got the force of the pinion as 1997.8, and for the gear we got 643.5 pound force. The contact force for the pinion is 237.16, and for the gear is also 237.6 pound force. After we did all the calculations, we got the factor of safety to be 4.07, which is more than the minimum required factor of safety. And after we finished with the gears, these are our results for the input and output shafts. The length of the shaft we found was 6 inches. The number of cycles is more than 1 million for the input shaft and also for the output shaft, which means both shafts have the infinite life. The inner and outer diameters for the shafts are as shown in the table. Finally, the factor of safety of the inner and the outer diameters are 2.2 and 3.06. It obeys the minimum factor of safety.
Once we found the radial loading on the shafts, we determined a deep groove ball bearing would be the best selection for the first bearing supporting the input shaft. Then, a single row ball bearing was selected for bearings 2 and 3. And finally, we selected an angular contact ball bearing for bearing number 4 because it can withstand a small amount of misalignment for the shaft to enter the coupling. For all of the selected bearings, we performed the necessary calculations to find the C10 values for each bearing. All of the calculated values were less than the catalog descriptions for the bearings we found, and therefore we determined that the bearings were safe and a good choice for our design, as you can see here. For the keyways of both shafts, we calculated the minimum length to prevent failure under the shear stress the keyway will endure. Next, we found the minimum length of the keyway that must be able to resist from crushing. From these calculations, we found the minimum length of the input shaft's keyway must be 0.042 inches, as seen there. For the output shaft, we found the minimum length to be 0.028 inches. Once we found these lengths, we calculated the factor of safety for bending and shear forces. All of the factors of safety for the keyways we found to be above 10, and this allows us to assume that these are properly selected and the right selection for our project.
In conclusion, in our design process, we made sure to follow all the client requirements, which are we got a factor of safety for the whole system larger than 2, and the gain ratio between a 10 and 2.5, and infinite life cycles. Some of the component of the design has a high factor of safety. Due to that, it may increase the cost of the production. Thank you.
Thank you for coming to our TED Talk. No engineers were harmed in making this film. Maybe one, maybe your eyes. We apologize, but Also, one of our team members, Mohammed, was not able to make it. He's in the hospital, so please keep him in your mind and in your prayers. Thank you so much.